Welcome back to Think Thrice. Today we're going to solve a fun geometry problem. So the problem we're going to take a look at is this one right here, where if you're a fan of Harry Potter, you may see that it looks kind of like the Deathly Hallows. And what we're going to do is we're going to find the area of this area at the top as a function of the height of our triangle. So the height of our triangle can change, and as that changes, how does this area change? So what I'd like to do, so go ahead, if you'd like to pause the video and give this a try yourself, go ahead. If you're more interested in the solution, then we can go ahead and dive right in. So if I'm looking at this area up here, well, the first thing I'm going to notice is the symmetry in my shape. So I notice that this left half of my shape is exactly the same as the right side of my shape. So all of the areas are going to be the same inside of here. So I'm going to simplify my problem just finding the area of this one side over here. The next thing I'm going to notice is that this area, if I was to break up my triangle and look at this point at the origin, or not the origin, at the center of my circle, and go to the edge of my triangle, finding this area A, so I'm going to call this area A, that's going to be the same as finding the area of this total triangle minus the area of this portion of my circle here. Okay, so that's what we're going to start with. We're going to start with that area A is equal to the blue area minus the green area. Okay, so in order to get started here, I need to know what's going on with this area here. So I'm going to define a few variables, a few unknowns that we don't quite know what to do with yet. So first, I'm going to look at this side Z. So Z is going to be this portion of my triangle here. It goes from the intersection of the circle to the corner of my triangle. I'm going to look at this side over here. So this side, I can see that this, if my radius is here, I have my radius in my circle, then the side here is going to be x minus r. I can see that this portion of the triangle here is 1/2 of the total portion. That's going to be 3. And my overall side over here, by the Pythagorean theorem, is going to be the square root of 3 squared minus x squared. 3 squared plus x squared, sorry. All right, so I have a few knowns here, a few things that I have a few unknowns. So right now I don't know what z is, I don't know what r is, but hopefully I'm going to be able to find those. Okay, but I did say that I have this overall area here in the upper portion of my triangle, and that's what I'm going to focus on. So I'm going to go ahead and draw that out here. So that's a right triangle, and I have this portion of the circle that's coming up as well. And I could continue this circle around. So if I'm going to find this total area, what I want to find first is the area of my triangle. So my area of my triangle is going to be given by 1/2 times my radius times this side that I defined as z. So I'm going to have 1/2 r times z. For my portion of the circle, so this green portion right here, the way I'd like you to think about that is as a portion of the whole circle. So let's say we have an angle theta there. So whatever that angle is, the area of that circle is going to be the area of the whole circle times that angle divided by 2 pi, or 360 degrees. So it's a portion of the whole. So that green area is equal to phi, or phi, over 2 pi times the total area of that circle, which will be pi r squared. Okay, so I'm going to go ahead and cancel a few things here. So these pi's go away, and I'm left with just phi r squared over 2. So my total area is going to be 2a. So the total area I'm looking for is 2A, which is then 2 times this blue area minus this green area, which is then going to be 2 times RZ over 2 minus phi r squared over 2. We get a little bit more cancellation with all the 2's. So my total area that I'm looking for is going to be RZ minus phi r squared, and that's my expression I'm looking for. Unfortunately, as of right now, I don't have r, z, or phi, so that is a little bit of a problem. So let's go ahead and see how we can get some of these values. Okay, so I'm going to look at similar triangles as my method of getting here to my solution. So I'm going to draw my first triangle I'm going to be looking at. So I have this triangle with a right angle, and I'm drawing it right there. And I've already defined this angle as phi. And right now I'll call this other angle theta. I'm going to draw a second triangle here. And this triangle shares that angle theta, and it's also a right triangle. So this is going to be a similar triangle to my original triangle. So using similar triangles, I'm able to do a few expressions here. So the first thing I'm going to do is I'm going to look at this z side, this r side, this x minus r, and this other side over here. So I have my bigger side, which is the square root of 9 plus x squared. And then I have my base, which is 3. So if I'm looking for first an expression to simplify r, so let's say I want r. It'd be great if I could get r in terms of just x. So let's use the sides here that only have x and r in them, and let's come up with an expression. So if I look at x minus r over r, so the hypotenuse over the opposite side from theta, that's going to be equal to the hypotenuse of my bigger triangle, square root of 9 plus x squared, divided by the opposite side on that triangle, which is 3. So this is just making use of those two similar triangles. So I can solve now, and if I want to solve for r, so I'm going to start off just by doing x minus r equals r times square root of 9 plus x squared over 3, which I can rearrange to get r times 1 plus square root of 9 plus x squared over 3 is equal to negative x. And if I divide that out, I'm going to get the radius is equal to that negative x times 1 divided by 1 plus the square root of 9 plus x squared divided by 3. Okay. And what we notice here is that we have a slight error in our calculations here, because we should have r times square root of 9 plus 3 is equal to positive x. So let's make that positive real quick. So that was a minor error there. Okay. So now that our algebra is straight, we can go ahead and work a little bit further toward our solution. So we're well on our way now. So now I have r in terms of just x. So that is great. So the next thing we need is it'd be great if I had z in terms of just x as well. So since r is already in terms of x, if I could get z in terms of x, that would also solve our problem here. So if I look at similar triangles again, I can see that z over r is equal to this x side divided by 3. So rewriting that expression, I get z is equal to rx over 3. All right, so now z is in terms of r and x. And since r is already in terms of x, I now have z totally in terms of x. So this is great. The last thing I need is an expression for my angle phi. So my angle phi, looking at my overall triangle, from the similar triangles again, I can see that this angle down here in the bottom right is also going to be an angle phi. So to get that expression, I can just take phi as the arctangent of x over 3. Okay, so I'm taking the opposite side over the adjacent side. All right, so now I have everything I need for my solution. So this total area is going to be equal to rz minus phi r squared. And now I can substitute in these known quantities. So my area is going to be r, which is x over 1 plus the square root of 9 plus x squared over 3, times z, which is r times x. So this whole thing was r, so I can just square this, multiply that by x over 3. And that's going to be minus my phi, which was arctangent of x over 3, multiplied by r squared. And that r squared, that's going to give me, once again, x over 1 plus the square root of 9 plus x squared over 3. And that whole quantity is squared. Okay, so I can see that I can simplify this just a little bit. And I can get that my total area is going to be equal to x over 3 minus arctan of x over 3 multiplied by a quantity x over 1 plus the square root of 9 plus x squared divided by 3 squared. And this is going to be my solution. So it is not pretty, but I can confidently say that that is going to give us our area. So thank you very much for joining me in this solution here. So hopefully this was a fun little exercise in geometry to get your juices flowing. Feel free to like and subscribe if you enjoyed this content. And if you'd like me to do any problem you've been scratching your head about, go ahead and send it in, and I'll upload it for a future video. Thanks again, and think thrice.